really important is cleaning out this trough. This trough, let me get my hand back here, hold on. This is what I'm pulling out of the trough. So all that's happening is when you wash it off, it just builds right back up there. There's still, I mean, I could just reach up there and grab more handfuls of it. There you go, more. And then now it'll start draining.
This video is brought to you by Sporlan, quality, integrity, and tradition.
We're called on the beer walk-in today not working, and went downstairs and the beer walk-in is at 60 degrees. All the fans are running, so that kind of leads me up here to the refrigeration rack where we can kind of open a few things up, see what's going on in here. All right, my beer walk-in right here says that it is system C as in Charlie. And we got some buzzing contactors, that sounds nice. But system C is right here. It is not in a defrost. System C right here has double breakers because it's a beer walk-in with a freezer coil. So we have a heater breaker and then a walk-in or compressor breaker. So my problem doesn't seem to be there. All of my condenser fan motors are running. These two are an ice machine, so we're not concerned about these. Compressors in here. System C as in Charlie is right here. It is not running. It is warm to touch and it has a cold suction line. Interesting. All right, at this point, there's a lot of, I don't know if that's oil. I don't know, but there's definitely a lot. Yeah, it looks like it just shut off. We're gonna have to put some service gauges on this bad boy. But if you look right here, it looks like there's a refrigerant leak on this oil pressure control, or I mean this low pressure control capillary somewhere too. Okay, the sequence of operation on this system is that the time clock, I just know this, okay, the time clock sends power downstairs. Come over here, I'll show you guys the time clock. On the number 4 terminal, the number 4 terminal runs downstairs to the, goes through the temperature controller. Once it goes through the temperature controller, and when the temperature controller calls, it opens up the liquid line solenoid valve. The liquid line solenoid valve allows refrigerant flow to run through the system. The refrigerant comes up on the suction line, and the compressor is turned on and off via the low pressure control. We also have, this is a dual pressure control, so it also monitors high pressure too. So high pressure and or low pressure is what turns this compressor on and off. In our situation, the compressor's not running. I'm pretty confident I'm gonna have a refrigerant leak based off of the oil that I see right here. Okay, so we're gonna open up the pressure control and we're gonna simply test across the pressure control, okay? And see if we have an open signal. Now, right now, we do not have an open signal on the pressure control. So that is actually not a good thing. We should have an open signal if it was a low pressure issue, where it would show 208 volts, and it is not. Let me make sure that I'm on there good. And I am. And we are not getting 208 volts. So our next step is to figure out why this guy right here is not turning it on and off. I thought that's what would have been it. So we're actually gonna step back a little bit. So if we come on over, oh, that does not look good. Look at the beer walk-in system C. Look at how the contact, I don't even need to go there, but let's do it real quick. So let's test the breaker. 205, we're testing from phase to phase. 205. And my battery just died, go figure. But we'll go get a new battery, but I have a feeling we're gonna have an issue with the contactor. All right, so let's go ahead and start. Okay, let's test at the top of the contactor. 208, or 205, 205, 205. So we have 3-phase coming in, and we don't have 3-phase coming out. Yeah. So we've got a bad, let's just check voltage drop. It'll tell you right now. 119 volts is the voltage drop across the C phase on this contactor. The other ones are fine. So we've definitely got a bad contactor here. So let's go ahead and power the system down. And we're gonna need to look into replacing this contactor. We're gonna start by double checking voltage to make sure that it's dead. It is. Let's check to ground. Let me find a good ground. That's a good one right there. Nothing. So this guy's dead completely. No power. All right. The contactor I have is a little bit different. It doesn't have lugs, but I think I can make it work. 208 volt. Everything's correct on that. I'm going to go ahead and get ahead of the game here. Y'all know how I roll. And switch over this cover. Yeah, that guy's gonna go in there just like that. Gotta be careful. Now in this situation, I'm gonna go ahead and shut down the rack. I can do it live, but there's no sense in doing that today, so I'm just gonna shut everything down real quick. There we go. Now we have a dead rack. You can't always do that, but in this situation I can. It really helps to take a picture sometimes, that we don't gotta like mark the wires, or you can mark them. I'll mark them too sometimes. But this time I'm just gonna take a picture. That way I have a reference to follow. I kind of already see what's going on here, but I will give a couple marks on things that I might mess up. Cool, looks good. All right, we're all wired back in. Everything's nice and safe. I went ahead and put this cover on, flipped this contactor around. Since I have the power off, I'm gonna go ahead and flip this contactor around too, the cover. Okay, cross your fingers. One, two, three. Please don't blow up. All right, it started back up. Nothing blew up. And the system is running. Got a cold suction line. And at the moment, a clear sight glass, but we got to let it run for a little while. I'm going to investigate this refrigerant leak right here and see what's going on with that while I'm waiting. Little tip, if you see a situation, especially on a service cap, where you see potential refrigerant leak, and or typically what I do is I don't remove the service caps, okay? Turn the system off, or in this situation, I just went ahead and sprayed it with soap bubbles all over the place, using the Big Blue. Love that stuff. But sometimes it could be in here, and it could be on the cap, and by removing it you could solve the problem. Same thing on the rotolock, disturbing things, it could be on this cap. In this situation, the refrigerant leak is actually on the capillary for the dual pressure control. All right, in this situation, we know that the refrigerant leak is right there, but I'm doing a big picture quote here. Okay, we're gonna see if the customer goes for it. We're gonna quote to replace the dual pressure control because we have to. But I also don't like the looks of this suction service valve. It's completely rusted out, pitted out. And a replacement of that suction service valve would not be too hard. What we would do is just unsweat this 90 right here, and replace this little section of 1 1/8 all the way down to the suction service valve. Now the trick is going to be to get the correct suction service valve, because the aftermarket suction service valves usually don't have double ports. So oftentimes you have to find the correct Copeland part number. It could be a little tricky, but I'm going to do some research and find this service valve, and we'll replace that whole thing. The discharge side looks good, everything else looks good. We'll also change the liquid line filter dryer, and we'll make note of the system charge, which is 25 pounds. So we're going to go ahead and let the customer know the potential. It's not going to take 25 pounds, but the potential that we might need 25 pounds. So that'll be in my quote, but I'll just let them know that we'll only use what we use, that kind of stuff. But yeah, that's where we're at. So I don't think this is going to leak out. The sight glass isn't flashing. I think that I caught this soon enough before it became a real problem. This unit does have a head pressure control valve, but the head pressure control valve is really not going to bypass right now, being that we're in the middle of summer. So I think we're going to be just fine. Come on, guys. Did you really think I was done? You know I can't leave well enough alone. Just walking around looking at everything. First off, I cleaned up this electrical section because, yeah, didn't like that. Come over here just to give a quick glance. And what do you know? This rack is dirty, to say the least. Just a little, right? So we're gonna go ahead and clean this guy up. By the way, this is that receiver for that system. That thing is about 3 feet tall, I think. It's a pretty big boy. I'm gonna get my stuff out. We're gonna go ahead and clean this rack. She needs to be able to breathe. We're supposed to have a little heat wave this weekend, so I do not want to be out here on a weekend call. We still need to quote the repair, but that's all stuff I got to order, so I'm gonna go ahead and finish this up, clean this rack. Opening up the condenser to look at it, someone's cut out the head pressure control valve completely. There's not even one there. It looks like this was way before me because I didn't do that. But yeah, so we don't even need the full 24 pounds in this guy. So it's not gonna take that much refrigerant. But all right, we're opening this up to go ahead and do a cleaning. I shut down the entire rack, and we're gonna clean from the inside out as usual. I'm still surprised at some of these stores that I took over. They're using lamp cord, guys. I mean, it's probably 16 gauge for condenser fan motor. And it's not even like protected. It's just running through, like, it's silly. Oh boy. All right, well, I'll recommend that to the customer too. I don't know if they're gonna wanna fix that or not. This thing, the fact that someone used that, these racks have a history of wire rub out, so it probably has a, will need a whole pipe, you know, kind of electrical thing. I don't know if they're gonna approve it at this time. I'm also gonna clean up all these zip ties and stuff from these condenser fan motor changeouts. Use the Viper brightener on this one because it's kind of greasy a little bit. So this is really good at breaking down the grease, but you have to be careful. You don't want to leave this stuff on too long. So So I'm using the Refrigeration Technologies coil gun. It looks similar to the other manufacturer's gun. I'm using an attachment one that's made by someone else, but the gun itself has a different dilution ratio. So on this one, I'm mixing it on the B ratio, and that's gonna use very little cleaner. And you'll notice that I've only got a little bit of cleaner in there. That's more than enough cleaner for this entire rack. This stuff is highly concentrated. Okay, we gave it a rinse from the top, and then now we're just knocking all the big stuff off from the bottom, and then we're gonna apply some cleaner to it and get cleaner on the inside of the coil. I like to get way back in there with the wand, that way you can really get the stuff off. And like I showed last time, really important is cleaning out this trough. This trough, let me get my hand back here, hold on. This is what I'm pulling out of the trough. So all that's happening is when you wash it off, it just builds right back up there. There's still, I mean, I could just reach up there and grab more handfuls of it. There you go, more. And then now it'll start draining, but yeah, you gotta clean that trough out. So I'm gonna get in this guy. I think I showed this on the last one, but there's this whole trough up here, and it gets full of gunk and dirt. So you gotta make sure that you're rinsing that out along with cleaning the condenser, or it's just gonna suck back up on the condenser when it dries out. So I just realized I saw water pooling up while I was cleaning, and I noticed there was no drain holes in this rack. So I had to drill 2 of them until my drill battery died. 2 little guys. I'm gonna try to push out the rest of the water, but hopefully we don't have any electrical shorts. I'll have to open up those electrical boxes and double check. All right, I did my best. Drilled a couple more drain holes inside. Rinsed out as much mud as I can, washed as much down the drain. There's a little residual still left. I'll give it another rinse. Quite a bit came out. It's kind of drying up pretty good. It's not perfect, still a little bit in here, but can't always be perfect. At this point, I'm gonna go ahead and fire this guy up and hope that nothing blows up in my face. I'm gonna be lucky if nothing shorts, because yeah, I got pretty wet in there. Condenser fan motors are on and running. Compressor B, we're gonna do this slowly. Make sure everything starts up and runs. Compressor B, just pumped down, so it's waiting for, that's the walk-in freezer, so it's actually waiting for the temp control probably, because it's got a digital temp control. System A. It's nice and slow. There's D. A's running. D's running. Now at this point, this thing's been off for about an hour and a half. Everything should be running. Everything should be calling. Go ahead and turn on system C. And we're gonna set the time 2 o'clock. 2 o'clock. One over here. 2 o'clock. Come on. Stupid thing. Now I realize why someone left that off. All right, 2 o'clock. So every compressor should be running now. 1, 2, 3, 4. They're all running. We're gonna let them run for a few minutes and the sight glasses should clear out. This one's flashing, but it also just turned on. It's got a wet condenser. It's gonna take a few. Everything else is clear. That one's clear. That one's clear. Beer walk-in's clear. So the cook's drawers is the only one that's not clear, so I'm gonna watch it for a little bit. All right, everything's good. Rack's running. Sight glass is clear on this little guy. Condenser's clean, it's dried out. I'm screwing all the panels back on, and we're gonna go ahead and submit that quote to repair it. We are back today. The customer went ahead and approved the repair. So, like I said, we're gonna go ahead and change the dual pressure control, change this valve as it's rusting out real bad, and then we'll go ahead and change the liquid line filter dryer. Shouldn't be a hard repair. And remember, because someone already pulled out the head pressure control valve, honestly, we really don't need it here. It's not that big of a need. So I'm not gonna bother putting it back in. So we don't even need to worry about the flooded charge then. We're just gonna clear the sight glass. Well, yeah, we're gonna get started. All right, we're getting ready to recover right now, and I wanna point out, really important, this unit's maximum charge or total charge is 25 pounds. I don't think it has that much because the head pressure control valve's not in it anymore. And for some reason, I think I put that dryer in there. I think, if I remember right. And if that's the case, I only charged it to a clear sight glass. I get mixed up on these things because I work on so many that look the same. So with that being said, if this unit has the full 25 pounds, the problem is that that recovery cylinder cannot hold 25 pounds of refrigerant. Even though it's a 30-pound cylinder, does not mean it can hold 30 pounds of refrigerant, okay? Based off of the refrigerant type and the density factor of the refrigerant, only a certain amount can go in. So in actuality, we can only safely put 22 pounds of refrigerant in that cylinder. So we have to watch this. That's why it's so imperative that you use your scale and make sure you don't overfill cylinders. You don't want to have a vessel blow a soft plug. I mean, you'd be lucky if it blew the soft plug, you know, or the pressure relief. So we're gonna pay attention to that. I've already purged everything. So in this point, we can just basically open the high side. Compressor's turned off. We're pushing refrigerant in. We'll let it push what it can. I already zeroed out the scale. Doesn't sound like it's pushing a whole lot right now, so we'll go ahead and hit start. Scale's running, machine's running, and we're gonna let it go, and we're gonna watch for 22 pounds of refrigerant. My machine was kind of knocking. Let's see, so I throttled it. You can throttle on this one. It's not bad anymore, but as it was knocking, I was just throttling it down, slowing the flow. But you could just listen, the machine was going, you know. All right, well, we're just recovering from the high side at this point, so we're just gonna let it keep going, and we're at 6 pounds at the moment. I've also got the handle right there too, 6 pounds, so okay, let it keep going. It looks like we're just gonna make it, because we're at 20 pounds and we've got 14 PSI, but notice something. Notice the discharge pressure of the machine, okay? That pressure is so high because the tank temperature is so high. You have to understand that this is a compressor and it's discharging gas, so it's compressing it. The gas is getting hot. On top of that, it's pushing it through a smaller hose. Now, I use 3/8 hoses to make my process go faster. If I was using 1/4-inch hoses, it would take even longer, and the temperature of the tank would probably get higher too because it's struggling. You could always set the tank in an ice bath. I mean, they make like sub coolers and things like that, but I'm not in that big of a hurry. We're literally almost there. So normally if it was a really hot summer day, 404, 410A, I'll just submerge the tank in ice water and it'll push the process along real fast. But got the nitrogen tank hooked up and we're doing a slow purge through the system. Right now I've got pressure that's too high because what I did was I was testing the solenoid valve and I went on the high pressure, the test feature. So we're waiting for it to bleed out all the remaining pressure, and then we'll get on the braze function. So I turned it off, and so it's slowly bleeding out. We've already started disconnecting the control. We did have to turn the power on, but we isolated those wires in this junction box so that way they're not live. At this point, we're going to change out the pressure control. Well, we can actually, because we're going to change out this valve first, then we'll slap the pressure control on there. As far as this valve, I think what we're going to do is cut it back here because I don't have the 1 1/8 outlet. I have a 7/8 outlet, which will be fine. So we'll come out and then we'll go to 1 1/8 right here is the plan. This is what we're going with. We have it all mocked up, just making sure everything fit. It's nice and good. Then we're going to go ahead and take it off, deburr it, sand it. We'll get everything, all the heat compounds and stuff on here to protect it. We've still got nitrogen flowing through too. So, all right, we got the Viper wet rag on there. I just got it goobered all over it back there to protect the insulation. We're gonna get ready to braze this bad boy. Using a rosebud tip, and we're using silver solder. I put a fluxing agent already on there. We're using 56% silver. Plenty of solder on there, just need to get it to flow down into the fitting. Looks good. Okay, now we're not going to waste silver solder on the top joints. Whoops, got a little too hot. We'll just your normal 15% sulfos up here. We are purging with nitrogen too. Okay, so this is a rosebud here. You can't fuck it up. Alright? The key to this one, actually looks like we're running out of ones. The key to this one is to heat this, but you just don't fucking go with it. So. Okay, so heat the copper first. Back. There you go. Get it all around, go underneath, go on top. Okay, that's plenty. Now just, you gotta be moving fast. You don't want to leave the heat on there. Okay, now on the joint. Yeah, there you go. That's good enough. Keep it on the copper too, right there. Just get it to melt on there so you can see the flow. Okay, now, use that to manipulate it. When you see it go in, you know it's time to put more solder on there. Keep it in one place. Keep it in one place now. Okay, now move it to the side. Alright, I'll do the side. You can't keep it in one place at a time. Okay, there you go. Okay, now hold on, take it off. Right here. Side up. Okay, now you've got plenty of solder. So now what you're going to do is just get it going. Okay. So the rosebud, you can ruin everything with the rosebud really quick, or you can make the joint happen real quick. Now this back one is tricky because you can't see it. So the back one, you're going to heat the copper. Okay, and then now notice what I do here. Okay, remove this, kind of to burn everything. I'm going to get this to flow. Once I get that to flow, then I know I got enough on there. And I'm just going to kind of use it to go like this. Because you're kind of doing it blind, you can't see everything. Good. We got a little drip. It's like, okay, so there's a drip coming off there. That means we have way too much solder. I feel more comfortable about it. So we're going to inspect these braze joints. We don't know that we're done yet or not. Alright, we are all brazed. Everything's good. Inspected all the fittings. They look good. Again, I run heavy on my solder, so, and then the silver solder, or brazing rod, whatever you want to call it. This looks good too. We'll sand this up and get the flux off of it. And then we'll put the Teflon ring in there. We still got to change the dryer, and then we'll get the vacuum flowing on it. Okay, we're gonna work our sensing bolts over where they need to be. like that. I'm gonna take some Nylog assembly lubricant, put a drop right on the mating surface where the flare spins, and then just a tiny bit on the threads. I'm gonna screw this guy on there. Remember, the Nylog just acts as a lubricant so the flare nut doesn't grab the copper and twist it real bad. You're always gonna have some twisting. Okay, I've shown this a bunch of times too. So what I'm gonna do is I'm actually gonna twist it a little bit out, snug it, see, but I want it to turn because inevitably it's still gonna turn a little bit. So when we turn it, it's gonna turn down to where I want it to. There we go. Nice and good. Okay, nothing's rubbing, nothing's gonna break. I like it. Okay, and then we'll do the other side now. Same thing. Littlest bit of Nylog right here. There you go. And then littlest bit of Nylog right here. Tighten and then twist it back because you're always going to get a little bit of spin no matter what. Okay. And then just make sure that it's not going to hit anything. I actually prefer it to be like that. Okay. Lines are safe down here. We're good. All right, now we're going to put the Teflon ring in here. And then we'll snug this guy down. Okay, so what we're going to do is take the tiniest bit of Nylog. I'm going to kind of move this out of the way. Just put it right where the Teflon ring is going to go. Snap the Teflon ring in. Rub the Nylog on. Now, for this fitting up here, I'm going to take a drop of oil. This is not going to get in the system. Nylog is cool to use too, but it gets kind of messy on the Rotolock fitting. So we're just going to drop a dab of oil on the back side of the Rotolock fitting. There you go. Just to make sure the Rotolock spins nice and good. Tiniest, you don't have to do this on a Rotolock, but I put the tiniest bit of Nylog on the Rotolock threads. And then we're going to thread it on. Thread it on by hand. You're going to do the same thing where you kind of pull the Rotolock valve the opposite way, because when you tighten it down, it's going to twist a little bit. Yeah. So we're going to twist it the other way, snug it. One more good little turn on it. There we go. Nice and snug, didn't ruin the Rotolock valve or nut. Everything's good on that. And then now we just need to change the dryer and pull the evacuation. I put my micron gauge over here, okay? We're still pulling high pressure because I just started pulling the vacuum. We got a giant mess going on. We'll start cleaning that up. Now I will say something, we're hooked up. We're pulling from the high side and the low side, but solenoid valve's open, but I will say that the entire time I was doing this, I could smell refrigerant boiling out of the oil. So even though we were flowing with nitrogen, we still were off-gassing refrigerant the whole time too. So I don't know that we're gonna pull a perfect vacuum on this too. I wouldn't be the least bit surprised if there's more leaks in it too. So we'll see how it all works, but we're gonna start cleaning up. Oh, and we got the dryer changed out. You know, I love going in with the flare dryers. I use the Sporlan catch-all because they're just, I just love those dryers. But come over here and I'll show you. So we go back in with the flare dryer, see that? And then we got the flare sight glass. Just makes it so much easier, one less thing to do. And again, these catch-alls are badass. So microns reading, once we get down to about 1500-ish microns, I'll go ahead and close the gas ballast. Vacuum went good. currently charging. So I cut rushing through some things, but what I did, I've shown it many times before, I closed off all the valves, hooked up the service gauges to the ports, but I didn't open them, and then hooked up the 1/4-inch process hose to the vacuum pump, evacuated the gauge hoses, closed this down, opened it on that, purged here, and then opened the system. So currently we're charging. We've got 11 pounds of refrigerant in there right now, 12 pounds of refrigerant. So we're putting in what we can into the high side. I have the breaker off, so the solenoid valve's still closed, so it's just dumping it into the receiver. And then we'll start it up and clear the sight glass, add the refrigerant. It may not take that whole charge. We'll see. All right. Here goes nothing. And we'll come over here. Wait for the solenoid valve and the temperature controller to turn on. Here we go. See if we can catch where we cut in at. Oh, my bad. I never hooked it up. I had forgot I unhooked it in here. There we go. Now we're running. All right. So I hooked it back up. We're going to be low on charge. I'm going to have to clear the sight glass. I'm going to pay attention to the sight glass and make sure. I'm going to let it run for a while. Like I said, it may not take all the refrigerant because the head pressure control valve's no longer in the system. So try to grab the remaining refrigerant, slap the unit into a defrost. Should pump down, and because I have this open, it's sucking the refrigerant out of that bad boy. I'm going to let that pull the remaining refrigerant out, get as much as we can out of that guy. Okay, the glass just cleared up. It's looking good. We're going to watch this guy come down in temp, but I'm just going to run down there and make sure that the box temp is good, and we're going to call this one a quit. And we are nice and cold. It's about 34 degrees in here right now in the beer walk-in, so we're looking good, looking really good. So
It started out just as a call, you know, beer walk-in, but we can't just go in there and solve the contactor problem and call it a day. We have to keep looking bigger, okay? Always look bigger, always try to figure out everything. Now, the customer may not always approve everything, but at least you went to them and gave them the full diagnosis, right? So after I replaced the contactor, I found that the condenser was dirty. I went ahead and cleaned the condenser, and then we quoted the repairs for the pressure control that was leaking. Now, the system wasn't even flashing yet, but it was something that we took care of. I brought that to the customer's attention. They approved it. We changed that service valve, you know, got them up and running to the point that everything is operating as good as possible, basically, okay? Customer was really happy, but again, I can't stress enough. We don't just go in there and solve the first problem or symptom, really, you know, and just ignore the rest of everything else. Okay, just like I said in the video, you guys know better than me. I'm always going to try to go through there and spend a little bit more time and double check everything, okay? But again, keeping the customer in the loop, letting them be in part of that decision-making process, okay? I really, really appreciate you guys taking the time to watch these videos. Do me a favor, if you guys are interested, go over to my website, hvacrvideos.com. Check out shirts. We have small, medium hats. The large hats are still coming. They're not in stock yet, but we have the small, medium, and we have plenty of the shirts, the sizes, all the large, all the way down to, I think, small. We have plenty of those too. So check it out if you guys are interested in that. Please consider, if you guys are considering buying any tools, check out TrueTechTools.com. You guys can use my offer code BIGPICTURE, one word. You can save 8%. I get a small commission from that. Helps to support the channel. You can also just check in the show notes. There's other ways to support the videos too. So again, really, really appreciate you guys. Remember, live streams Monday evening, 5 p.m. Pacific time, work permitting. I talk about these videos, kind of go over questions that I got and different things like that. And this week, coming up Friday, we will have the HVAC Overtime Show. It is our 50th episode of the HVAC Overtime Show. Come check it out. We are going to have Clive from Big Clive Live as our special guest on the show. Myself, Adam, Joe, and Bill will be on the show as usual. So come check it out on the HVAC Overtime YouTube channel. Okay? We will catch you guys on the next one.